Hi, welcome back. So in the previous video, we looked at how concentration affected rate. Um, with this one, we'll kind of continue on and look at how temperature affects rate of reaction. But first, I have to remind you that because temperature is the same thing as average kinetic energy, okay, Ke is the energy needed to do work. Okay? And work can be several different things. Okay? Work can mean forming bonds, breaking bonds, or they can simply be used for moving molecules or atoms. So movement of molecules or atoms. Okay? So if we were to look at our original container that had, I believe it was like 3 molecules of oxygen and 3 molecules of hydrogen, okay, and let's say that the average temperature here is 20 degrees Celsius, which is room temperature, okay. What you would see is these guys would be moving slowly, and once in a while they may actually collide with another molecule, okay, and perhaps the right molecule, but the movement is slow because there's not as much kinetic energy. But the easiest way to fix that is to simply add more heat. Okay. It's not the only way, but if we use our Bunsen burners and we heat up this beaker or container, okay, by adding heat, the temperature will increase, right? And the movements now will reflect that, okay? So there's more movement of molecules than before, and they can move around in any direction, okay? And with more movements, there could be more collisions, right? So increasing temperature, in a way, increases kinetic energy, which in turn increases the number of collisions that we have. The more collisions that we have, the more products that can be formed. Okay, so in the end, an increase in temperature will increase the rate of reaction. And if we take away heat and decrease temperature, that will also affect rate by decreasing the rate. Things will work a lot slower. Now, I said that heat is one way of increasing our kinetic energy, but it's not the only way. Okay. Shaking, stirring, and or agitating they're all are effective ways to increase kinetic energy. Okay. They don't necessarily increase temperature, but it does increase the amount of energy going towards movement. So more temperature, faster the rate. That's usually a pretty easy one to understand as well. The next one that I have planned up for you guys is called surface area. Okay. And most people they don't define surface area very easily, okay? Because you're not supposed to use the word surface or area in the definition, but this is how a chemist would define surface area. It's the amount of space and or exposure reactants can have with other reactants. Okay, so that last bit is for the chemistry definition of surface area. So if we take a look at what this actually means, okay, let's look at a reaction involving iron plus oxygen to form iron oxide, okay, which is a solid. So you have a solid and a gas to form another solid, okay, which we know as rust. So I'm not going to worry about balancing the reaction here. I just want to show the difference between surface area and how it affects rate. So if I start with, let's say, a block, okay, of iron, right? And that iron block is made up of many atoms of iron. That's all packed in, okay? So right now you can only see the ones that I'm drawing out, okay? And we have oxygen molecules surrounding this block of iron. These oxygen molecules can only react with what's on the surface, okay? And that's it. So here you have an example of decreased surface area. Okay. When things are more compact, the surface area is decreased. But if we decide to somehow crush or break that iron cube into a powder, and then you spread it out, like this, you'll now notice that your oxygen molecules, they have more surface to react with now. Okay, so this is Fe, still a solid, but as a powder. Okay, whereas this is Fe as a compact cube. So here we have an increase in surface area, or basically more exposure. So by increasing the surface area, you create more exposure and therefore more collisions. So increasing surface area causes increased collisions, which increases the rate of reaction. So these are just the first three, okay? Concentration, temperature, surface area. There are actually a few more that we'll get to in our next lesson.